is junction rule? Let us understand. This is a junction of a circuit, and a number of currents are either coming out or entering to the junction. You can see that in this diagram, I1, I3 and I4 are outgoing currents, whereas I2 and I5 are incoming currents. So, the junction rule states, in an electric circuit, algebraic sum of currents meeting at any junction of the circuit is 0. So, mathematically we write sigma I equal to 0. Sigma I equal to 0 means here if you consider outgoing current to be positive and incoming currents to be negative, then suppose outgoing currents we are taking positive. Outgoing currents are taken as positive and incoming currents are taken as negative. You can consider incoming positive, outgoing negative, no problem. So sigma I equal to 0, I1 is outgoing current, so it is positive. I3 is outgoing current, so it is positive. I4 is outgoing current, so it is positive. I5 is incoming current, so it is negative. And I2 is incoming current, it is negative. So sigma I equal to 0 means I1 plus I3 plus I4 minus I2 minus I5 equal to 0. So it states that I1 plus I3 plus I4 equal to I2 plus I5. It means total outgoing current is equal to total incoming current. So this is the junction rule or first law given by Kirchoff, and this is called Kirchoff's first law. So you can understand it deals with law of conservation of charge. What is this loop rule? This loop rule states that the algebraic sum of changes in potential around any closed resistance loop is 0. You can see it is a closed resistance loop. An algebraic sum of potential difference means mathematically delta V equal to 0 in the closed loop. So how many loops are there? We can see one loop A, G, B, C, B, A. Another loop G, F, E, B, H, G. These are two loops we can see here. Suppose this current is taken as I1, this current is taken as I2, these two current join here, and this current is I1 plus I2. This side again I2 and this side again I1. Now the current distributed in the circuit in this way, that is cell E1, it gives the current I1, cell E2 gives the current I2. These two current join together through R3, I1 plus I2 is the current passing. Then at point D again they split up, I2 move along G and I1 move along the line CA. Now let us see the loop rule, how to consider the particular loop and how to write the equation. Consider the loop A, G, H, D, C, B. Consider this loop. Which loop we are talking about? A, G, H, D, C, B, A. Now for each section we have to write down potential difference. For example, VA minus VG, then VG minus VH, then VH minus VD, then VD minus VC, then VC minus VB. You can take the decision by taking these points. AG, so VA minus VG, next GH, so VG minus VH, next HD, so VH minus VHD, next DC, so VD minus VC, next CB, so VC minus VB. Now let us see VA minus VG. So VA minus VG, here no resistance, so potential difference is 0. Because we know potential difference is I into R. If R is 0, then potential difference is 0. Then VG minus VH. VG minus VH, if you consider, between the points G and H, two terminals of cells are there. One is positive, one is negative. So G is at higher potential, H is at lower potential. So VG minus VH will be positive because bigger minus smaller is positive, and the voltage is considered as E2. Next is VH minus VD. If we see VH minus VD, the direction of arrowhead is from D to H. So D is at higher potential, H is at lower potential. So when we calculate VH minus VD, then it is lower minus higher, so its sign is negative, and potential difference is current into resistance, so current is I2 and resistance is R2. Next is VD minus VC. Again, between D and C there is no resistance, so VD minus VC is 0. Last is VC minus VB and VC minus VB. So what is VC minus VB? Current is flowing from C to B. So C is at higher potential, B is at lower potential. So VC minus VB is bigger minus smaller, so it is positive, and I1 R1. Last is VB minus VA. VB minus VA. If we see the point B, it is at lower potential because it is at negative, and A is at higher potential, so it is positive. So VB minus VA is smaller minus bigger, so its sign is negative and it is minus E1. Now if we add all these equations, then left side all the terms cancel out. So left side result 0, and right side what we get, the equation left side is 0, right side is 0 plus E1 minus I2 R2 plus 0 plus I1 R1 minus E1. So we write E2 minus I2 R2 plus I1 R1 minus E1. So we can write the equation I1 R1 minus I2 R2 equal to E1 minus E2. This is equation 1. This is how to set the equation for the loop A, G, H, D, C, B, A. In the same way, we can write another equation for the second loop. Now let us see how to write the equation for the second loop. The second loop is G, F, E, D, H, G. Suppose this path we are considering. You can also consider the reverse path. The result will be same. Now let us consider the loop G, F, E, D, H, G. Remember the point from which you are starting, come back to the same point through each junction. G, F, E, D, H, G. G, F, EBAG. So what are the terms we are going to get? VG minus VF, first term, VF minus VE, second term, VE minus VD, third term, VH minus VD minus VH, next term, and VH minus VG is the next term. Now let us see VG minus VF. VG minus VF, no resistance connected between G and F, so this result 0. VF minus VE, current is flowing from F to E, so F is at higher potential and E is at lower potential. So VF minus VE is bigger minus smaller, so it is positive. Current is I1 plus I2, resistance is R3. Next is VE minus VD, no resistance connected between D and E, so its value is 0. Next is VD minus VH, arrowhead is from D to H, so D is at higher potential, H is at lower potential, so VD minus VH must be a positive quantity, and that is plus I2 R2. Now VH minus VG, if we consider, H is connected to negative terminal of cell which is at lower potential, and G is connected to positive terminal of cell which is at higher potential. So we get lower minus higher, the result is minus and it is E2. Again, if we add these equations, then what we get, all these terms will cancel out. 0 equal to I1 plus I2 into R3 plus I2 R2 minus E2. This is the second equation. We can write I1 plus I2 into R3 plus I2 R2 is equal to E2. This is the second equation we are getting on the basis of loop rule. So first law or junction rule, it is based on the law of conservation of charge, whereas the second law or the loop rule is based on law of conservation of energy.